Hey guys, this is Mr. Mauricio, and today's lesson solving right triangles, page 305. Okay, objectives for this lesson is to evaluate inverse trigonometric functions and find missing angles measurements and to solve right triangles. Now, um, remember we had that table on page 305. This will be very important for this lesson. So let's get started. So again, so far in chapter 5, we have learned how to use special trigonometric functions, right? Sine, cosine, tangent. Their inverses, cosecant, secant, and cotangent, right? And on lesson 5.4, we learn how to apply these trigonometric functions to find certain values of one of the sides of the triangle. So in lesson 5.5, we're going to learn how to use inverse of functions to find an angle. Okay? So look at example 1. So example 1 says, solve each equation. Sine of x equals square root of 3 over 2. So what we're trying to do here is to find the value of x, right? So as we normally do when we were solving quadratic any type of equation, to leave x by itself, we have to do the opposite operation, right? So the opposite of finding the sine of x is to find the arc sine or the inverse sine. So how do we do that? We multiply both sides of our equation, okay, by the arc sine or by the arc sine, right? The symbol for arc sine, instead of writing arc sine, is sine to the negative 1 of sine of x equals sine to the negative 1 of square root of 3 over 2. Notice here, since these two sines of sine to the negative 1 and sine of x are inverses, they cancel each other. So now we have x equals the inverse sine of square root of 3 over 2. Okay? So if we use our calculator, we will get our value. But square root of 3 over 2, the arc sine of square root of 3 over 2 is a special angle. So if we look at our table on page 305, and we want to find the values of sine, which is equal to square root of 3 over 2, notice that sine of theta equals square root of 3 over 2. Theta is 60 degrees. We have it again over here at 120 degrees. And so we have two values for x, for x equals square root of 3 over 2. You're going to write the following. Shift sine, okay, and square root of 3, parenthesis, square root of 3 divided by 2 close parenthesis. And that in your calculator, that will be equal to 60. That will be the value for your calculator. But we notice that from our table on page 305 that there were two angles. Remember, 60, right, and 120 are reference angles. 60 is for quadrant 1 and 120 is for quadrant 2. Now, example 1, part B, says cosine of x equals negative square root of 2 over 2. So we have to solve for x. Now, the inverse of cosine will be the arc cosine. So to leave x by itself, we have to multiply both sides by the arc cosine. So similar to cosine, instead of writing arc cosine on both sides, it is easier to write cosine to the negative 1 power times cosine of x equals cosine to the negative 1 power times negative square root of 2 over 2. Okay? Since cosine to the negative 1 and cosine are inverses, they cancel each other. So now we have that x equals the inverse cosine of square root of 2, negative square root of 2 over 2. So we have to go back to our table on page 305. Let's find the values for cosine equal to negative square root of 2 over 2. Here we have 135. Okay, let's see if we can find another one. Negative square root of 2 over 2, 225. Okay, then x equals 135 degrees and 225 degrees. Okay, so those will be the values of x for cosine of x equals negative square root of 2 over 2. Now, example 2 states the following. Evaluate each expression. Assume that all angles are in quadrant 1. So part A says the inverse tangent or the arctangent of tangent of 6 over 11. Okay? Look how simple this is. Tangent and arctangent are inverses. So what happens? They cancel each other. So your answer is just 6 over 11. Simple, right? Now, part B. Here comes the reasoning part. Cosine of the arcsine of 2/3. Cosine of the arcsine of 2/3. Okay? Yep. Okay, now, so we know the arcsine of 2/3 is it's something, right? So we can say then, from this part, we can state that sine of, I'll call this sine of A equals 2/3. Okay? By formula, sine of theta equals opposite over hypotenuse, right? So we have, since we are assuming that we're talking that the angle lies in quadrant 1, let's draw a triangle. Okay? This is our triangle. This is our right triangle. And we're going to call this angle A. Okay? I'm calling this angle A. So sine equals opposite of A. This is the adjacent of A, and this will be the hypotenuse, right? Sine of A equals opposite over adjacent. So that means that this is equal to 2, and the hypotenuse equals 3. Yes? And we need to find the cosine of the arcsine of that. So, using the Pythagorean theorem, we know that a squared plus b squared equals c squared. I'm going to call this a, b, c. So a squared, that is 2 squared, plus b, we don't know that, equals 3 squared. 2 squared, 4, plus b squared equals 9. So b squared equals 9 minus 4. B squared equals 5. Find the square root on both sides, and we get that b equals square root of 5. Sorry, square root of 5. Okay? So the arcsine of A is 2/3. So what would be the cosine of that? Simple. Cosine of A equals adjacent over hypotenuse, right? So the adjacent now is a square root of 5. So cosine of A will be the adjacent square root of 5 over hypotenuse 3. So the cosine of the arcsine of 2/3 is equal to square root of 5 over 3. Okay? Now, if we look at example 3, we have our right triangle. And the information given is the following. If side F equals 17, this is 17, and side D equals 32, find E. So we need to find angle E. Okay? So, with respect to angle E, what information do we know? We know F and we know D. So, the angle opposite to the right angle is the hypotenuse, so this is hypotenuse. And so this will be the adjacent side, right? Okay? So, using the trigonometric functions, adjacent over hypotenuse. What is adjacent over hypotenuse? That will be cosine of theta equals adjacent over hypotenuse. In this case, theta will be E. Cosine of E equals the adjacent side, F, over the hypotenuse, D. Now, we substitute. Cosine of E equals the adjacent, F, que es 17, equals D, which is equal to 32. So we know that cosine of E equals 17 over 32. But we don't want cosine of E. We want to find the value of E. So how do we leave E by itself? Okay, by multiplying both sides by the inverse of cosine, which is, arc cosine of -1. So we cancel arc cosine with cosine, and we get that E equals the arc cosine of 17 over 32. So we take out our calculators and we write shift cosine. Make sure that your calculator is in degrees, okay? Again, so we write in our calculators shift cosine parentheses 17 divided by 32. Okay, once we do that, our result in the calculator will be 57.91004874. So let's round to the nearest hundredth or the nearest tenth. 57.9 degrees. That will be the value of E. Okay? Again, by the information given, we have our right triangle, EDF. They told us that F was equal to 17, D was equal to 32. So, using the trigonometric ratios, we know that with respect to E, we have the adjacent side and the hypotenuse. So that's equal to cosine. Now we substitute and we multiply both sides of our equation by the inverse of cosine. O sea, arc cosine or cosine to the -1 power. And then we cancel, and in our calculator we write shift cosine 17 in parentheses, 17 divided by 32. Okay, close parentheses, and that will be your result, 57.9 degrees.